Hello and welcome to this session around Revit and Plant 3D collaboration in the cloud. Jose and myself are both AEC technical sales specialists with Autodesk in EMEA. The agenda for this session will cover first an introduction around what is Revit and Autocad Plant 3D. We'll then introduce Autodesk Docs, which is our common data environment. We will also see how to set up a collaborative project in the cloud. Then we will take a look at the design collaboration itself, with the first part around co-authoring design, both in the Revit and Plant 3D. Another important piece would be the cross-discipline collaboration using Revit, Plant 3D, Navisworks, and of course our cloud tools. And we will then cover in product collaboration directly in the authoring tools. Jose will then speak to you about coordination, so the different coordination workflows we can present here and issue management. Let's start with the introduction. What is Revit and what is AutoCAD Plant 3D? AutoCAD Plant 3D is a desktop piece of software which covers spec-driven workflows for both P&ID processes and 3D piping. As I said, AutoCAD Plant 3D covers the production of P&ID drawings based or not on specific piping specification, which are of course also based on manufacturers' catalogs. And AutoCAD Plant 3D also covers 3D piping and of course supports and some light early stages steel structure. Out of the process drawing and also the 3D models, the 3D piping drawings, we can of course extract reports, list, and bill of materials, as you can see it here. And as a final deliverable, we can generate directly isometrics and bill of materials, the associated bill of materials. And we can also add drawings that we call orthographic drawings for general arrangements and bill of materials, associated bill of materials. Revit is our multidiscipline BIM solution. A Revit file is a database, which is the building information modeling database in this case. A Revit file is composed of parametric families. Parametric families can be objects, views, etc. Revit is composed of three main disciplines. It will cover architectural, structural, but also MEP models, which are mechanical, electricity, and plumbing. Revit is more building oriented than Plant 3D, which is industrial piping solution in our portfolio. Let's say a few words around Autodesk Docs, which is our common data environment in the cloud. As you can see, our large portfolio called Autodesk Construction Cloud contains this, is based on this common data environment, which is Autodesk Docs. And the reason of having a common data environment is to connect in an efficient way all the disciplines that are working on a project, from the architect to, of course, the client, but also engineers, contractors, subcontractors, project managers, project coordinators, and so on. This is just a simple example of how the different teams, split it in disciplines here in this example, can contribute and work in the same common data environment, and how BIM managers can actually coordinate and organize these multidiscipline workflows that all teams can easily use. So the data is at the center, sitting on the Autodesk Docs, the common data environment on the cloud. It can be reached from within the authoring tools such as Revit or Autocad Plant 3D. We can also manage different exchange formats such as IFCs, as you can see it here. And also this common data environment, Autodesk Docs, can be reached from a Windows computer using the desktop application desktop connector. Our Autodesk Construction Cloud solutions are built on Autodesk Docs, which is the common data environment. We can then add Autodesk BIM Collaborate, which covers the design project collaboration and coordination. And we can also add BIM Collaborate Pro, which will cover the co-authoring tools, mainly Revit, but also Plant 3D and Civil 3D, those three main ones. This is why we stated here that we have a specific component with this BIM Collaborate Pro solution, which is composed of cloud work sharing for Revit, collaboration for Plant 3D, and collaboration for Civil 3D. Let's take a look at some of the main features of our common data environment, which is Autodesk Docs. The idea is to be able to securely manage team members, to implement and manage, of course, a folder structure and the permissions to these folder structures and the data that we can actually have in the folders. There's also another feature which is called file locking, which can be, and you will see it a bit later in this presentation, can be automatic when we're working from Revit or Plant 3D, but it can also be done manually, for example, by administrators. We also have a glimpse of the fourth main feature here, which is version control, um, and have the ability to have the full version history and full control on this version history. We can also use our common data environment for file sharing, just simple file sharing, for example, share a specific version of a file with the owner. And people can also interact with the data that sits on the Autodesk Docs using, for example, markups or issues. And we will illustrate issues towards the end of this presentation. Let's take 2 minutes to define like 3 acronyms we will use in the following minutes of this session. ACC means Autodesk Construction Cloud. This is our platform that covers all the different phases of a project and all the different solutions that we can actually provide. ABC means Autodesk BIM Collaborate. We just mentioned it, but this will be the acronym in the future. And ABC Pro means Autodesk BIM Collaborate Pro, which is intended for co-authoring in the desktop tools. Let's spend a few minutes around setting up a project on the cloud. So how do we set up an ACC project? How do we create it? And how do we manage teams so they can actually share their data in a very efficient and simple way? To create a project, so you can see it's very simple. As you can see on the image on the left, and let's also take a look at this short video. So once the project is created with the full details, address, etc., we can actually create teams that have a specific folder, a specific space on the common data environment, and also where members are invited and have specific access rights. We can also easily choose which folder in that space to look in. So the system understands what content, what models are needed to be parsed and to be showed either to the team, either to external teams that will require the information to be shared. So these specific permissions can be easily set up, and that's very modular and flexible. This is just one example of permission settings here. For example, we can actually have a team project folder, just like I just said, with a specific permission level set up for either companies or groups or specific individuals. And in case we need um, different permissions for process drawings and 3D models, we can easily set them up by, for example, like you can see it on this picture here, creating groups, PNID editors, and 3D content editors. So again, this is completely flexible and can be actually adjusted to the needs of your company and also the needs of every project. Because most of the time, I mean, all the time, every project is different. Let's take a look at how it works now for Plant 3D, for example. So we basically um, have a vision of the cloud, as you can see on the left here, on Autodesk Docs in an internet browser. And on the right, you can actually see the collaboration cache that is on your computer. And the idea is, of course, to sync the collaboration cache that sits on the local laptop or PC with the cloud. And this is how it works. For example, for an AutoCAD drawing, the Plant 3D drawing or Civil 3D drawing, in this case, um, we can see it on the cloud. And then when somebody needs to work with it, he or she performs an operation of checkout, which results in locking the file on the cloud in the master project, checking it out. Um, this person can actually modify the file, so co-author it, add new elements, and well, perform design tasks. And once this person has finished, the local file version, of course, is incremented in the meantime. Once this person has finished, he or she checks back in the file on the cloud, which will result in releasing it and and in a file version incrementation on Autodesk Docs. Again, we follow the full history of file versions, so we can easily have a view on every version that has been uploaded or checked out. When working with Plant 3D and cloud projects, for you who are familiar with the project manager of AutoCAD Plant 3D, this project manager will provide at any time the file status of the files you are working on and the ones that your colleagues are working on, because again, we are in a co-authoring effort here in Plant 3D. So as you can see, we have a legend here. So anytime um, you will know if the file is either reserved, checked out by any other members of your team, or if it's available for you to work on, of course. Let's say a few words about the project file actions. So these check-in, check-out ideas that I presented a few minutes ago, um, for the sake of simplicity in terms of working every day with Plant 3D, they can be automated. Automated, for example, when the drawing is opened, checkout can be automated, or when the drawing is saved, the system can actually automatically perform a check-in. And this is um, your choice, your administrator choice, and your choice as a user to simplify the way and basically reduce clicks. Also, when we are talking about design collaboration for Plant 3D, as you can see here, you have a view of the design collaboration module in a web browser. The timeline you can see here describes different sharing packages that have been created and shared by your team or for your team. And we wanted to stress the fact that as Plant 3D works a lot with external references, XREFs, is specifically for the 3D models, our system and the design collaboration modules understands perfectly these external references and can actually show them to you in this web browser interface that can be both useful for the team members, the designers, and also for coordinators or BIM managers. Let's take a look at the Plant Cloud Collaborative Project Administration. So again, for an admin in Plant 3D, we can actually edit the different project setup while users still work on their drawings in the project. So this is because the project setup also has a check-in check-out system that can actually lock it on the server when it's in use by an admin. So this is a huge advantage compared to other local workflows. And also, we have a new feature that helps our users and our admins to back up either a local or cloud plant project at any time. This could be easily scripted and automated as well. I propose now we take a look at how to set up the plant and the Revit environment to work with the cloud with a short video here. We are now in Revit and we chose to show you in a very easy and quick way how to collaborate. So we can actually choose what we need to publish, 3D views, 2D views, or of course sheets, deliverables. And we can easily initiate collaboration using this collaborate button here. We will point at a project in the cloud and point at a specific theme that has been created just like we showed it before, and we can actually save it. The work sharing will start as soon as the project is saved in the cloud. Now, if we consider Plant 3D, we are working here on a local project, and as in Revit, we will start collaboration on the cloud, choose the specific, select the specific project on Autodesk Docs, and upload the local files to build the master project on the cloud. This is a web browser view where we can actually take a look at what has been saved as a master project in the cloud. And in this case, for Plant 3D, we can actually, so it's saved at the root of Autodesk Docs of the project files folder, but you can easily move the whole Plant project to the specific themes you have created, if you have created them before, of course. So again, this is flexible. Either we create the themes before pushing the content to the cloud, either we upload the content and then we create the themes. This is to show you the flexibility of the system. And when going to the design collaboration team management, we can actually easily go to the Plant 3D project folder that we just picked. And for the sake of simplicity, select specific folders. So for example, just the Plant 3D Models folder in a Plant project. So the system will only parse these ones and only will show and analyze these 3D plant models. Let's now spend a few minutes around co-authoring design in Revit and Plant 3D. This is this is the classic server-based collaboration or on local area network or wide area network that we had for a few years now. And this is how it works for Plant 3D. Um, a Plant 3D project has a SQLite or SQL Server database that can be used by many users depending on the different projects we work on. For Revit, the workflow would be similar with a central model sitting either on a local file server or on a real Windows server. And team members can actually work on their local models and eventually reserve worksets or elements in the Revit model and synchronize that way with the central model that sits on the server. Cloud-based collaboration is a bit different. Um, First, we do not need servers. The data resides on the cloud on our Autodesk servers, so it's a ready-to-use solution. So the data sits on our common data environment, which is Autodesk Docs, and all disciplines, like in this example, structure architecture, MEP, um, can collaborate on the same Revit models or specific models linked one to each other. We could also add, of course, civil 3D drawings from engineers and plant 3D drawings, being process drawings or 3D models. And they all are on this common data environment, which is Autodesk Docs. So a few fundamentals of ABC and ABC Pro. For specific cloud work sharing workflows in Revit, we can actually see that we have a specific space, of course, on the desktop, on the computer, and we will use the Revit Cloud Work Sharing service to interact with the cloud. First, when the collaboration is initiated, we have here the version 1 of the file A. And then, depending on the choice that has been made, we can actually publish documents on Autodesk Docs that will be visible in an internet browser with the Docs module. So the publishing can be manual or automatic. Then we can actually still work on this file locally on the Revit desktop and synchronize to make it a second version on the cloud that is reserved for the design team. The design team will actually work on many different models and create many different versions synchronizing with the cloud. These different versions can be only seen in Revit. They are not visible. The only version that is visible in a web browser on the cloud for now is the V1. Once the design team decides to publish that and to make it visible on Autodesk Docs in an internet browser, for example, for an owner or a BIM manager or coordinator, they can manually or automatically publish the new version, which we will make it a version 2 that is actually um, accessible in an easy way without having to open Revit to consultants or the client, for example. Let's see how it works. So while in Revit here, we will just directly in the new interface, pick up the specific project, the specific folders, and then open the cloud model. Um, this will either download the model and its linked files, or just update it in case the local file already exists on your machine. The linked files come from the cloud as well, so they will be updated just as if they were linked locally once the other disciplines will update them. The synchronization of the file is done just like as if we work again with a local server. It's exactly the same process. And the publishing process that we have described a few minutes ago can be done from Revit or automated again, for example, during the night if we have a lot of data to publish. Let's now take a look at the co-authoring plant design in Plant 3D. So here you can see that we have checked out a specific piping drawing that we wish to modify. We need to know that this user A is working on his drawing. Once the design is over, he or she will check in the drawing, and another user B that has user A drawing as an external reference can actually work from the same equipment and have the impact of the design of user A. He will be alerted by the change of the linked model. So we are all working on the same projects, of course, split it by specific drawings that are linked together, just like we showed you in Revit. Here we just modify a valve. User A modifies a valve, changes the drawing, saves it, and checks it back in. And you will see the impact, the direct impact on the cloud in the specific plant team. User B will then be alerted of the modification and can eventually adjust the design accordingly to what user A has modified in the project. Now we have seen the co-authoring in Revit and Plant 3D. Let's discuss cross-discipline collaboration. Firstly, here are some fundamentals of ABC and ABC Pro. In terms of terminology, of course, so a team space consists in a folder where the work in progress files are. The shared space is the folder where the models are made available to other teams, other disciplines, for example. A set is composed of views or sheets published from Revit, and this is the designer's choice before publishing. A package is a set plus the Revit model that can be shared with different other teams and or disciplines. Sharing is making a package available to the other teams, of course, and consuming is copying the package into the team's own shared space, so shared folder, the team's folder. Let's now take a look at a workflow example. With three teams here, we have an architecture team, an MEP team, and a structure team working in Revit and using the Revit Cloud work sharing. They all three have their own models in their own team space, of course. And as they're working on the modeling and design in their own work in progress space, they actually create new versions of the file by synchronizing their modifications, so the other team members can have the latest changes. Now on the common data environment, which is Autodesk Docs, and that can be accessed on a web browser, we can actually have the architect, the MEP engineer, and the structural engineer um, publish in the published space the latest version of the design that their own team had provided. And then should they like to share their design with the other disciplines, this is where the design collaboration module and the timeline comes into place. So the timeline will show you all the different um, models published, of course, in terms of there are squares on the timeline, and when needed, these team leads, I will call them that way, the architect, the MEP engineer, and the structural engineer will decide to share packages, so the round dots on the timeline, with the other teams. So the next step will be, of course, to accept or consume packages from the other teams. In this example, you have seen the architect accepting and consuming packages from the MEP firm and the structure one as well. The black and purple dots here, and this is, of course, valid for all the other teams that are actually consuming content from the other disciplines. So this is a quite visual way um, to see that. Um, Again, this is about the same view, but looking at the hierarchy, the folder and subfolder hierarchy. This would be the architectural space composed of the folder and the subfolder named consumed. This will be the structure team space, the other MEP team space as well here, with their um, work in progress models, in this case one per team, and then the shared space where the shared packages will go once the team leads decide um, to share the work in progress. So this is exactly what I told you on the timeline. The packages, the shared packages, will be drawn as rounds on the timeline, as you can see. If a circle is empty, it means that it has not been consumed. If it's filled, uh, it means that it has been consumed. So this is where the shared models will go and then will be consumed by the other discipline teams. Let's watch an illustration video around this process. So this is the design collaboration timeline. As you can see, we are part of team number 5, industry, called industry Revit. We can actually see the team's models here. We can turn them on and off, of course, in terms of visibility um, to uh, to uh, to have them available, and we can share them as a package. So we are choosing to share models, or we could actually add documents as well. And this team number 5 will share models with all the other teams. Now we switched teams. We are in the coordination team, the team number 10, as you can see it. We can easily perform a live review to check the models, including their properties and the object properties, whether they come from Plant 3D or Revit. So these are intelligent models that we can actually check for review in a web browser in the design collaboration module. The next step would be to analyze changes of these shared packages. So this is what this short video is about. Um, this is a quite new feature in the design collaboration module. We can actually follow specific changes of a group of objects, for example, of a model. So basically here we can actually choose, for example, a pipeline, the one that has 1, 2, 3 as a tag. We can save it for later, and every time that external team will share a new package with us, we will be able to filter their model to analyze changes only on this specific line that we just saved, which is a huge help in terms of analysis. So this is exactly what we are going to do. Now, if we take as an example, the other team that changes a design in Plant 3D. So for example, in this case, adds a valve. The version will be incremented on the cloud, of course. And now the other team can actually follow the changes and analyze them. So you will see that the system, the version comparison feature, will show the change on this specific watched line. You can see that the valve was added in the latest version, and we can actually compare with the version with the previous version of the file. So we consider this, of course, as essential. We can also check the properties of an element, just like we did in the previous step for the live review. Let's now take a look at collaboration in the product, meaning in Revit and Plant 3D. There are many ways to link Plant 3D files to Revit and the other way, Revit to Plant 3D. We selected with Jose two of them. I mean, one specific to send plant models to Revit, which is based on the Navisworks format. We selected this one because it's actually the simplest, maybe not the most complete or the smartest, but the simplest, definitely the simplest, and doesn't necessarily require Navisworks on the computer. I will say a few words about that in a few minutes. But this is why we selected this methodology. It's not the only one. It's not the only format that we can use to send models from Plant 3D to Revit. We could also consider DWG or IFC with an external plugin, for example. Um, this one again is simple and easy to use and doesn't require Navisworks. So the only thing to do here in Plant 3D is to use this command Navisworks NWC out and to save upload Navisworks to Autodesk Docs. This can be automated with Desktop Connector. And then in Revit we can insert the coordination model, which is the NWC file. The other way around, from Revit to Plant 3D, we selected the same easy to use and quite intelligent method, which is also based on the Navisworks the Navisworks cache file, NWC file. So in Revit, we just need to go to the add-ins, external tools, and then save the NWC file and eventually upload it directly to Autodesk Docs with Desktop Connector if we need automation. In Plant 3D, we just can XREF it in a very easy way in attaching the coordination model, the NWC file. Again, those two methods are not the only ones, but we chose them because they are the simplest and the most accessible, and they don't require installing Navisworks on the user's machine. So let's illustrate that with a short video here. We are in Revit. I will use the coordination model command. The export from Plant 3D has already been done. I'll just go using Desktop Connector to get the file on the cloud. So basically, I'll choose my project files, and then the specific shared folder we use to exchange the NWC file coming from Plant 3D. And this is exactly what happens here. We have the NWC file, and we can actually use the Plant 3D file in an easy way and see both files in context. The Plant 3D files also appear on deliverables in a Revit. So this is also an advantage. And the other way around, if I consider an NWC Revit exported file and I need to import it again with the Autodesk Desktop Connector from the cloud in Plant 3D, this is how I would do it. I just choose the project exactly the same way, and I will choose the Revit NWC file and just insert it as an external reference. As you can see, we can then model around the Revit file respecting the specific project context. To export NWC files from Plant 3D and Revit without having Navisworks manage or simulate installed on that specific machine, here's the link to the small installation file that is called Navisworks NWC Export Utility that you can actually download on our site, internet site, and use to create Navisworks NWC files out of Revit and Autocad without having to install Navisworks. It can, of course, be done with Navisworks, within Navisworks, of course. If you would like to use Revit for 3D piping instead of Plant 3D for 3D piping, then we have a feature called Revit PNID Modeler in Revit for you. So there are a few things to know about this kind of workflow, which is very specific. Um, so it matches your needs if you use Plant 3D plus the cloud, so ABC Pro, to create your PNIDs, your process drawings. If you don't need isometric drawings, because Revit cannot, as is, generate isometric drawings. There are external plugins, but as a standalone product, it cannot generate isometric drawings. And also, if you are willing to either use your existing Revit piping content or are willing to create some Revit piping content, which is not as rich as the Plant default piping content. Let's illustrate that with a very short video here. We are using Plant 3D in a cloud-enabled project to draw PNIDs. As you can see, we can access the different properties. Since it's a cloud-enabled project, we can see the PNID on Autodesk Docs, and we can use here in Systems the PNID Modeler tool in Revit to select a specific PNID in a cloud project on Autodesk Docs. We need to do some mapping of the system types and the object mapping as well in Revit, because systems and objects do not have the same name in Revit and Plant 3D. And then just pick up the line in the Plant 3D diagram of your PNID generated with Plant 3D. And we will have the line and the inline elements that appear here. Everything in green has been already created in Revit. Everything that's gray needs to be added in the Revit model. So this is how it works. We will choose just a specific pipe based on the PNID diagram coming from Plant 3D, and just add, for example, this piece of pipe, this segment here, that turns green. So we have a very nice check system, which will tell you anytime if components from the PNID were added to the Revit 3D model or not. I will now let Jose take you over the next section, which is all about coordination and issue management with Plant 3D and Revit files.
Thanks, Alex. Now let's talk about coordination and issue management. Coordinating trades and designers is consistently identified as the highest value BIM workflow among all the project stakeholders. Project teams can save many millions on a typical project by identifying and resolving problems and fixing them before they get on site. Coordination is like checking for spelling and grammatical errors when we write a book. However, typically in construction, the full spelling and grammatical checks happens at the construction site, leading to extended coordination cycles or errors and mistakes on site, which require expensive rework. If we follow this analogy, when we start writing, the text editor has a quick error checking tool, the autocorrector, that spots every single mistake we do. This fast autocorrector would be like using the interference checker within Revit, something that designers can do autonomously and on a daily basis. Once we advance in the writing process, we must check the spelling and grammar, something that we do not need to check daily, but is very useful as is an automatic process. Model coordination brings the automatic clash detection instantly and enables users to assign clashes with a due date to track resolution and accountability of issues easily, for instance, on a weekly basis. Last but not least, a proofreading analysis is needed, and this is usually done by an expert who analyzes the document following certain guidelines. This requires the intervention of clash detection experts and specialized skill sets and tools like Navisworks to handle only the most complicated coordination issues. As you can see, we use different solutions depending on the different stage of the writing process or project stage, but simply connected by a common environment using Autodesk Construction Cloud. Coordination is often perceived as a specialized activity, with the BIM manager or virtual design and construction team serving as the single point of contact for the design and trades teams. This results in a very time-consuming process for trades, who must constantly work to keep the BIM coordination team updated with design changes. In a typical coordination workflow, each subcontractor, consultant, and trade team builds their own model, then shares that model and data with the BIM manager or BIM coordinator, who federates them in a product like Navisworks. The BIM manager analyzes the model for clashes, generates a clash report, and shares that report with the design teams, generally at a weekly coordination meetings. Discussions are had and each team goes back to work to resolve the clashes that were assigned to them. This process gets repeated until the coordination issues are resolved. Yes, this process can work, but it's a very long process. Issues that could have been identified immediately are not seen until the coordination process happens. And if the design teams wants to look at clashes on their own, they need to have first Navisworks and have access to all the multidiscipline models. But a large problem that usually goes unseen is the amount of time the BIM coordinator or BIM manager spends on non-optimal activities, serving no other purpose than making sure the latest models are aggregated or federated together and clash detections has been run on the latest models. We understand that this is far from being ideal. This diagram might help you to visualize the complete coordination process and how it's connected with the BIM coordinator to visualize, manage, resolve, and report clashes. Multiple coordination spaces enable the definition of private space for individual trades, in addition to a formal coordination space typically managed by the BIM coordinator or main contractor. Starting from the first steps of the process, design teams and trade constructors are already uploading their models to the CDE, sharing packages in design collaboration as we have seen before. where they can share and iterate their content. Model coordination monitors private coordination spaces for each trait and automatically aggregates the models and analyzes them for clashes, reporting the results in a clash matrix for review and prioritization by the trait coordinator and the design team. All the project members with access can leverage clash status and issue management capabilities to resolve conflicts quickly and efficiently in the design tool like Revit or Plant 3D. As next step, design managers or design project leaders can publish a new version of the project and share it in addition with other traits for a more formal coordination analysis led by the BIM coordinator. Later in time, BIM coordinators can easily federate those models shared by the different traits, run automatic clash detection in the formal coordinated space, and decide if a rule-based analysis with Navisworks for further analysis are needed or not at a specific project stage. After prioritization, the BIM coordinator can assign issues downstream, monitor the status of those issues, update clash status, automatize reporting by scheduling one-time basis, or recurring reports to be discussed during coordination meetings and inform all the project stakeholders at any time. Automated clash detection means that any project stakeholder can upload models to the command environment and have them clash check instantly. In other words, project team members can take responsibility for clash detection, speeding up the overall coordination process and freeing up the BIM coordinator or BIM manager to focus on complicated clashes and oversee the process rather than be the bottleneck. As Alex has explained before, teams are created to represent a company or a specific function within a company. We have seen what happens between design collaboration and document management, where every team has their own space to work and collaborate. We will have similar behavior with coordination spaces, where a project administrator creates a coordination space and configures it against a folder in document management. Models uploaded to those folders are coordinated and automatically checked for clashes. Team members with access to the folder can then upload models. Once the folder structure and models are in place in document management, users can access to model coordination to view model data, filter and inspect detected clashes, and create and view issues. Prioritization is a key part of the workflow, and this will help us to focus on what is important to be solved quickly. The clash matrix in every coordination space will definitely help us to understand what is the current coordination situation, displaying a grid within all the clashes that have not yet been reviewed. Darker colored cells indicate where the most clash groups exist. The number of clash groups between each pair of models are displayed in the clash grid, and the total number of clash groups for each model are displayed below each model's name. A clash group is defined as the number of objects in the primary model, listed in the vertical column, that clash with all the other models in the grid. A singular clash is defined as the clash between two objects from different models. In order to properly work and collaborate in multidiscipline projects, Revit files, DWG, IFC, and NWC models are supported for clash detection. For IFC, NWC files is critical to ensure structure exports that allows model coordination to recognize and track unique elements ID. That's why model coordination only supports IFC exported from Revit, Autocad, and third parties like Archicad, Magicad, and Tekla. The clash matrix can only display 100 models at a time. So if you have over 100 models in your coordination space, use the filters to adjust the models that are shown. Coordination is a cycle task, so it's important to save as many time as possible in admin activities. Users can leverage what I like to call federated models, or save views, as it's called in ACC, to save a collection of models of interest as a group. Views are useful as they can be easily viewed and shared with other project members. They also enable project members to review clashes and issues for a smaller subset of data from a coordination space, like by floor or by specific location. When managing clashes, users will be able to group clashes by any property of a clashing object, being this a property from your Revit, IFC, or DWG files. These properties automatically are generated in the authoring applications such as dimensions or materials. This provides users even more granular control when reviewing clashes and also supports different languages attributes from the different authoring applications. Sometimes a clash can be ignored. For example, where a light fitting appears to clash with a ceiling, but is in the correct position. Removing these clashes from your views helps you work through real problems more efficiently. Once a clash or a clash group is determined to no longer need attention, you can mark it as non-an issue and move it to the Close tab. You can create an issue to indicate that something in the design requires investigation. Issues can be created from specific clashes using the clash panel or directly on a model using the Issues panel. We must click the model at the position of the issue to place a pushpin that will be seen by other project members with correct permission when the model is opened. We can edit the issues details in the panel to the right, like the title, status, and issue type. You can also add description of the issue, specify an assignee, start date, due date, location, location details, a root case, and priority. A screenshot of the model is attached to the issue when it's created. The pushpin is not included in the screenshot, so it's a good idea to select the element of the model that is at issue. You can also add references, such photos, RFIs, files, and assets, and of course, add comments. Assignees will receive an email notification with a link to the issue for quickly access, which accelerates the issue solutions process. When clashes are marked as an issue and assigned to the relevant project members, they are moved from the Active tab to the Assign tab. Here, the assignee, the owner, or other project members can view issue details and track the changes being made to resolve the clashes. All issues on your project are accessible in the Issues log, where you can also sort, filter, and search for issues in your project. Once you select an issue, you can edit its attributes as well as change the assignee and status to close the issue when it's solved. This makes it simple to identify problems, prevent delays, and manage work on your project. With better visibility and the ability to track progress, you will be able to deliver quality work on time. In this video, you can see all the steps that I just mentioned before. Starting from selecting all the different models that we want to aggregate as federated models from the CDE. Then we can save them as a view to be able to reuse them later. Finally, we identify a clash create and document an issue, assigning it to the design team in charge of solving them. It's important to note that cloud-based technology does not need to be a complete replacement for traditional coordination technologies like Navisworks, but instead, when used in conjunction with one another, they complement each other and add value to the process. The value of this approach is that it only requires the intervention of clash detection experts and a specialized skill set and tools to handle only the most complicated coordination issues and democratizes access to clash detection workflows. Being coordinators and other Navisworks users then get to take advantage of the latest released files being uploaded to the cloud by opening them directly, ready for your weekly or bi-weekly coordination meeting, and rule-based clash detection analysis using the Navisworks coordination issues adding. With the coordination issues adding, Navisworks users can open, edit, comment on, and resolve issues created from ACC clients, including design collaboration, model coordination, and document management. Navisworks users also have the ability to create issues within Navisworks and push through to the same ACC ecosystem, enabling all the team members to communicate seamlessly with other stakeholders. Issues are automatically loaded when models are opened by the adding, enabling users to view all the issues assigned to their model sets from specific coordination spaces and save views. The most powerful workflow enabled by the coordination issues adding is the ability to open and append all supported models files from model coordination directly into Navisworks. Then run a rule-based clash detection workflows and create issues directly in Navisworks, as we have seen before in the cloud environment, using the same interface across either desktop or cloud platform. Once an issue has been addressed or created in Navisworks, users will see them in ACC with model coordination, allowing real-time communication between both environments, providing a single source of truth for model coordination. The next step in the coordination workflow is to solve the identified issues in the authoring design tools. For Revit, we have the new Revit Issues add-in that helps Revit designers to easily understand the connection between an issue captured in BIM 360 or ACC and the Revit model in context. With the Revit Issues add-in, Revit designers can open, edit, comment on, and resolve issues directly within Revit. Revit designers can identify, position, 3D view, and involve element details. Issues are automatically loaded when the add-in is opened, enabling Revit users to view all the issues assigned to their models. When selecting an issue in the site panel, we automatically load the associated view and zoom into the pushpin with the correct camera position. When viewing an issue, the object the pushpin is placed is highlighted, enabling users to jump into the view and immediately start to make changes. Once the issue is resolved, the user can change the issue status and add comments before saving the model changes and publish a new version into the cloud. Unfortunately, we don't have similar add-in for Plant 3D, but good news, it's in the roadmap. So at this moment, we recommend to work with two screens, having one screen ACC or Navisworks opened to see the issues in context and Plant 3D opened in the other screen to do changes in order to solve the issues. Coordination meetings are a key part of the coordination workflow, where the wide variety of trades must be coordinated to optimize cost and reduce rework. To avoid having silos and be able to access all the relevant information from a single source of truth, ACC includes the option to host and manage meetings. This will help to track all the commitments made and centralize all the meetings records. Teams can create an agenda with the different topics to be discussed, their corresponding status, which people must be involved, document decisions, link issues and document, and assign people to action to be made, establishing clear accountability. Captured minutes can be exported to PDF, and follow-up meetings can be organized from existing meetings and carry over all the topics and documents associated. Coordination meetings are no longer a disconnected and time-consuming activity. Last but not least, the way we share information during the project is an important differentiator on how effective and fast we are able to solve problems. The report tool provides a central location to create, configure, schedule, and view reports. Project stakeholders from different trades can view a summary of critical and actionable information. We can save time with configurable templates and automatic schedule reports, giving time back to your teams by scheduling recurring reports for coordination, RFIs, meeting minutes, and more. Simply pick the cadence, start and end date, and assign recipients based on their name, company, and role, as well as share with non-project users through email. Anyone with access to a report can share the report with other team members. All recipients of the shared report are visible in the report tool. We hope you enjoyed this journey on how we can improve our collaboration with Revit and Plant 3D. We have seen ABC Pro as the perfect solution to empower collaboration with Revit and Plant 3D through a cloud-based environment, ensuring that all users have access to the right information at the right time, avoiding version mistakes with an automatic version control, having a common environment as the only source of truth of the project, being accessible 24/7 anywhere at any time, interacting with documents so you can quickly upload, download, block, and share them, using the version compare tool to understand which elements have been changed, added, or removed for better decision making, having complete traceability of each of the deliveries of the project between the different disciplines through the design collaboration module, working collaboratively in real time with the design solution through the cloud, increasing designers' productivity, analyzing and viewing in context all the federated models directly in a web browser, accelerating the review processes and democratizing access to BIM models. Finally, a robust coordination and issue management workflow through automatic clash detection analysis that is connected with Revit and Navisworks to drive efficiency on how we solve issues, reducing reaction time for resolution.